electrons better than whom? Who takes electrons away from whom? Let's say we want to write a spontaneous oxidation reduction reaction involving bromine and zinc. Can you find a half reaction for bromine? What's it look like? Br2 elemental bromine plus 2 electrons gives 2 Br minus. Can you find a half reaction that involves zinc? Cn plus 2 electrons gets you zinc metal. Okay? Now, those are the half reactions that we're interested in. How are we going to write a whole reaction? Got to flip one of them around, don't you? And which one are we going to flip around? Uh-oh, there were 2 things. Thank you. How we doing? Doesn't this reaction like to go this way better than this one does? Yeah. Doesn't this reaction like to go that way better than this one does? Yeah. Does that make sense? Yeah. So why not set them up so that they're doing what they want to do? This one likes to get oxidized better than this does. This likes to get reduced better than that does. Let's just turn it around, so that's what's happening. And before we add them together, we want to make sure what? Electrons cancel, or they're going to cancel, aren't they? So we'd have Br2 plus Zn0 gives us 2 Br minus plus Zn plus 2. How would you carry out this reaction? How would you actually do it? What am I going to get? Say, Mr. Companion, do it for us. What am I going to get?
Some E thing. Error.
Piece of zinc metal?
Just kidding.
And some liquid bromine. I got it. Now, liquid bromine is really hazardous to handle, so I'm not going to really open the bottle and do this. But this is what I would need to do that reaction, wouldn't I? Right? How we doing? Okay?
That was a tease.
Beaker, water, hydrochloric acid. I'm going to dilute it. So I have diluted hydrochloric acid. Yeah?
Yeah.
Okay. And I've got zinc metal. What can happen? Can an oxidation reduction reaction occur? If that's true, if an oxidation reduction reaction can occur, then the question is, will it occur? Okay, that's another question. But first of all, if it's going to occur, what's going to happen to the zinc? What is the only thing that can happen to zinc metal? Oxidation. The only thing zinc metal can do is lose electrons, huh? How do we know that? You haven't ever seen a zinc negative ion, have you? And you won't. Metal atoms don't gain electrons to become negative ions. Right? We talked about that a long time ago. Alright, so the zinc metal could could lose electrons to become zinc ions. What could it react with? What's in the beaker? Hydronium ions. We know it's a hydrochloric acid solution. 3O. What else is in the beaker? Chloride ions. What else is in the beaker? Water. There's hydroxide ions, but not very many, huh? Okay? Now, first of all, when we do oxidation reduction reactions, I know this is going to be confusing, we don't talk about hydronium ions, we talk about hydrogen ions. Because in an oxidation reduction reaction, what can happen to a hydrogen ion? Good. Gain electrons to become neutral hydrogen molecules, right? Or neutral hydrogen molecules could lose electrons to become hydrogen ions. So the fact that once those hydrogen ions are made, they join up with water molecules to make hydronium ions isn't really an oxidation reduction thing. So it's the hydrogen ion itself that would be gaining electrons to become hydrogen gas. So in the context of oxidation reduction, we don't ever talk about hydronium ions. We talk about hydrogen ions instead, even though we know that there are no hydrogen ions in this solution. We know those hydrogen ions are attached to water molecules. Okay? All right. So, what could happen to the hydrogen ions? They could gain electrons. Ooh, that's good, because our zinc has to lose, right? The hydrogen could gain electrons to become neutral hydrogen, hydrogen gas, right? Okay? What could the chlorine do? Can the chlorine gain electrons? Ooh, we know chlorine likes electrons, don't we? Could the chloride ion, do we expect that to gain electrons and become more negative?
No.
Neutral chlorine atoms like electrons a lot, don't they? Chloride ions are what they make after they've taken electrons. After they've taken on electrons. We don't expect the chloride ion to gain more electrons, do we? What about water molecules? Can water molecules gain electrons? Yeah, they can. Take a look at the half reaction. Can you find a half reaction where water molecules are gaining electrons? Where there's water on the left-hand side?
Yeah.
Where is it? About 10 up from the bottom? Okay. How are we doing? Okay. Find the place where hydrogen can take on electrons. Right about in the middle? Yeah? So water can take electrons. Hydrogen ions can take electrons. Who likes electrons better? Hydrogen ions. So who is zinc going to lose its electrons to? Hydrogen ions. So we expect zinc metal to react with hydrogen ions. And what do we expect it to make?
Zinc ions.
The zinc metal will lose its electrons and become zinc ions. The hydrogen ions will gain electrons to become neutral hydrogen, which we know is diatomic. Ooh, look, lots of bubbles. What's in the bubbles? Air? Oxygen? What's in the bubbles? Hydrogen. Complete the problem set, please, for Monday.